So fine, doing good.
Okay, great. So, Tejaswar, uh, can you please introduce yourself?
So myself, Tejeshwar, I am from Andhra Pradesh, and I have completed my graduation in 2020 from the JN2 College of Engineering, Pulvenzala, and I have completed my diploma in Government Polytechnic College, Nandyala, which is near to the my hometown. And I have completed my schooling from my village, almost 500 to 600 meters from my home.
You don't need to
And
mention these
I
things,
was
okay,
the
honestly. Okay, yeah. Okay.
I was one of my class topper in graduation and diploma as well as schooling. And I'm preparing from 2020 onwards. I'm preparing for various competitive exams.
So you have been in this space since last maybe 3 years or so?
Yes, sir.
Okay, great. Uh, okay. So number one, always whenever you give introduction,
Mm,
first thing, don't mention school. Mention diploma and
okay,
then
sir.
engineering, not the other order. Okay. I need to
Okay, okay,
hear
sir.
what you did, matlab, your most recent thing in the end. Okay. So
Yes, sir.
first you say I did my diploma from here, then my BTech from here, like that.
Okay, okay,
And
sir.
it's nice that you were a class topper. That's amazing actually. Okay, Tejaswar. So why do you want to
Yes,
join
sir.
BRC?
BRC. Actually, I was very fascinated about doing jobs in mechanical field, sir, and I was also interested to do jobs in dynamic field, like research oriented jobs.
So anyone could offer you a job in a research oriented dynamic field. Even private sectors offer you that. ISRO offer that. DRDO offer that.
But actually, I didn't given anything. But Barc is very like what you can say. It is very developing technologies are very
ISRO doesn't has
good.
any developing technology, DRDO. I mean,
No. So I couldn't say that. But comparatively, it is like what you can say as
okay, leave it.
uh,
You need to improve and at least prepare your answer. Okay, you are just shooting in the stars. Okay,
okay, okay, so
so you have a
okay,
good answer to why BRC. It should be specifically for BRC. Okay,
okay, so
yeah, you should have a good answer. You should have a good motivation like that. You have been doing this
okay,
since like 3.5 years. Okay,
yes, so
yeah, good. So Tejas, what are your commendable subjects?
BTD, HT, SOM, and FM, so
What is BTD?
basic thermodynamics.
Oh,
Yes,
yes. Uh, Thermo FM SOM.
sir.
What is
HT, heat transfer to.
okay? HT. What is basic thermodynamics? And how is it different
The
than thermodynamics? I mean,
actually in our engineering graduation we have basic thermodynamics. In that we have learned zeros law, first law, second law,
okay,
and
great. What is second law?
we have few substances.
What is second law?
Second law has two statements. So
Okay, I
generally,
want.
the second law
I,
is came.
I am aware of that. So, second law. Uh, can you tell me a statement of second law in terms of entropy?
Entropy. Like you can say, entropy of a universe is never decreases. So
Correct. And where does it remain constant? I mean, could it remain constant?
yes, so it can be remain constant or it can be increasing, but it never decreases.
Okay, great. So, yes, you are right. Now, tell me one thing. What is entropy?
What is
Entropy. What is entropy? What do you mean by entropy?
entropy means generally it is a disorderness of the molecules. So it doesn't have any specific definition, but we can say disorderness of the molecule. If disorderness is heavy in the molecule, then it will have high entropy. Like gases have more entropy compared to the solids. because solids are very closely packed molecules. They don't exhibit randomness in their molecular movement.
Okay, that's correct. Now, tell me one thing. Why do we have concept of entropy? Do you have any answer to that?
Entropy concept.
I mean, what exactly the second law essentially states?
Quality of the energy, sir.
Okay, great. So, okay, here's a question from Som for you. Okay, we have two fixed support. Okay,
Okay,
and
sir.
in between there is a rod, something like this.
Hmm.
Now I heat up the rod. What will happen?
Okay. There will be compressive stress developed in the rod, sir.
Correct. How much will be the compressive stress? Let's say delta T is the temperature increment. Okay, will the rod's length increase?
Alpha delta T is the stress developed in the bar, sir.
Okay, what will be the stress? We are more concerned with stress usually.
In mechanical oriented, the stress is generally whenever you apply certain force, the more in the solids, the
I asked
should
what
I
is
go a direct definition?
no definition.
I need to give direct.
No, I ask what is stress in this case? What's the quantity? What's the formula for the same?
Yes, sir. Stress is given by E alpha delta T.
Hey, Tushar, आपका interview I think I took in the morning, right? Tushar? Okay, anyway. So, you are
Yes,
right
sir.
actually, Tejaswar. Yes, आपका interview मैंने इस morning में लिया था, right?
यस सर मैं बस सुन रहा हूँ
Okay,
क्वेश्चंस.
great. Carry on, please. हाँ, Tejaswar, एक बात बताओ. In this case, will the rod length will increase?
No, sir. It will be not increase because we have restricted enough, so it not
Correct.
be increasing.
Now, can you give me some example in which the rod's length increase as well?
Yes, sir. If we if we have fixed only at the one end, if we hit, then it will have
No,
expansion, sir.
we have fixed support, no roller. We have fixed support.
Okay, then we have some gap between them, sir.
No,
Between the support.
we don't have a gap.
Let me. Even
We don't
gap
have a
was
gap.
not there.
No gap. Yes, no gap.
Yes, sir. We can say in the railway track there will be due to expansion there will be gap, na
The gaps are due to expansion or
contraction and expansion.
gaps are there to prevent the expansion.
Due to to prevent the expansion, sir. To
Okay.
prevent the expansion in the cold climate, where cracks are developed.
Correct. So my question is, in the case that I told you about, we have fixed support. You are increasing the temperature of
Yes,
the
sir.
rod. Will the length of the rod increase? If I am saying the rod length
Actually,
is increasing, what is that case? Can you please tell me?
rod can be increased. Length can be increases.
Yes.
Hmm.
Okay.
So both have fixed support, sir.
Both are fixed support. Yes.
There is no gap.
No gap.
Okay, then if I connect any spring, there will be chance, sir, between the support and rod.
No spring. Don't think that much. Okay. Anyone else? You have any answer?
Sir,
So not increase, sir.
if temperature decreases, we can say that the stress will be tensile stress. It is
Correct.
equivalent to length of increase. It is
Not
equivalent to
exactly.
length of
Not exactly. That is not what I want to get it from
and
here. If I give you
if
answer
only
now,
length,
you will think.
sir,
If
sir,
I give you
if
the
only
answer.
length,
Not increase.
no, sir, it will only length or breadth also we can take, sir.
No, not breadth. Just think about the length, Okay.
So total length change 0, sir.
It should be 0. Yes, I agree. But there is a condition in which the length there will be a little increment in length. I'm not talking about huge, but yes. Okay.
Sir,
Tejeshwar, what?
total. Okay, okay.
Okay, Tejeshwar, what is slenderness ratio?
Slenderness ratio. Effective length to the area moment of inertia.
Okay, now can you answer the question?
Effective length. Okay. If it is
The rod could
column
buckle.
life section. Yes,
It
sir.
does.
Like
It doesn't need to be a column. Like it could be anything. Horizontal, vertical. The buckling
yeah,
doesn't
okay,
care.
okay, okay.
Okay.
Okay,
Now if it
okay.
buckles, will the now if it's buckle, will the length increase?
Actually, buckling means it will be decreasing, sir. The diametrically it will be increases.
What? Repeat.
Diametrically, the expansion will be taken, but length cannot be increases, no, sir. Buckling conditions.
Okay. Here is a question. Okay, there is a vertical rod,
Yes,
and
sir.
it's both the ends are fixed.
Yes, sir.
Now I'm applying a vertical load.
Okay, sir.
How will the column buckle?
If it is long column, it will be going for buckling, sir.
Correct. Now in that
Like it
case,
will.
yes, in that case, the buckling here. Okay, I mean this diameter of the rod did anything. That's what I'm trying to say.
Yeah, sir. Got it. Yes. Effective length will be changes.
Effective length is a different parameter. Effective length actually depends on length of rod and the type of support we have.
If
Now
we
come
have
to
both supports,
okay, what I'll do,
then we
wait,
have
I'll
to.
I'll draw for you. Okay, yeah. Can you see my screen? Hopefully. Okay. You
No,
should be
sir.
able
It
to
is
see my
dark.
screen.
Yes. No. Okay.
And now it should be okay. Okay, so let's say I have these two are my fixed support and this is my rod. Okay.
Okay, sir.
Now I'm increasing the temperature. Obviously, this thing is fixed. This is also fixed, right?
Yeah.
So my rod will buckle something like this.
Yes, sir.
Are you getting it?
Yes,
There will be
sir.
a little increment in length, not lot. Okay. Given you all are here now, I'll come to the question that I had asked to Tejeshwar. Okay. So the same question for everyone. Okay, not just Tejeshwar, everyone. So we have a wage, theta, same. We have a spring, mass m. Okay. And the initial condition is release condition. That means x equal to 0. This is my initial condition. Now I let go the mass m. Now I want to draw a velocity versus x graph here. So what is my velocity as a function of x? I want to find this.
Sir, when it is compressing the spring, it will be SHM, simple harmonic motion.
Correct.
But when it is releasing, it is like the gravitation linear. It's kind of there the gravitational force and this velocity will be that kind, like it's like parabola, square, like square function. It will be this,
No, it
not
won't be
SHM.
square function. No, it will be still SHM. Yes. I say it's not even SHM actually. It has a fixed
Yes,
force
sir.
that is acting on it. So
Yes, sir.
when we
Yes, sir. Fixed force. Yes, sir. When
we can't
compressing,
really
it will
call
be
it
HM.
we can't really call it SHM actually.
Yes, sir.
It will be
Like we
different.
can say that potential energy is converting into kinetic. Kinetic energy is converting into potential energy while releasing.
Now we have two type of potential energy here. We have gravitational potential energy and spring potential energy as well.
So
And we have
spring,
kinetic.
it cannot, no, sir. Compressive spring, like when it releases, it shoots up. Like there is no point in the spring and the mass combined state. Like what I'm saying is, I think you are. I will show sir while drawing. Then I
Okay, yeah.
will
Okay,
in
do that.
detail.
Do that. Okay, I'll let you. हाँ, अरे यार, share notes. Okay. हाँ, please. Yeah, you can share.
Yes, sir. Sir, what I'm saying is, while suppose this is a spring, while compressing it, the mass and spring are in attached form only. There is no like, it is in a SHM then, but when it is in, like it releases, this will move fast compared. These both are not in contact. It have only this four, because if this spring is compressive spring, it like these
So
both are
spring
not in
is spring.
contact.
It could be compressive. It could be, tensile as well. I mean, it all
Yes, sir.
depends on the deflection.
Yes, sir. Based on that, the mechanics will be changing. If there is a hook and we attach the spring, then it has the spring force also. If like the spring
It is a
is this
hook.
kind
It is
of,
a hook. The mass is attached to
yes, sir.
spring.
Yes, sir. Then like compared to that spring, this spring, the mechanics will be changing. If it is a hook,
See,
there will be different.
unless and not stated, the mass and the springs are always attached. Okay.
Yes, sir. Like if we attach, then SHM and this force both will both act on this velocity.
Okay. So now you have to find out relation of velocity in terms of displacement.
It will be sinusoidal, sir.
No, it won't be sinusoidal. तुषार आप भी ट्राई करो.
So
Okay.
we can get V square equal to KX square something relation, no?
Maybe we can. You tell.
Actually, I'm getting V square equal to KX mg minus mg sine x minus KX square by 2 square by 2.
Can you please repeat? I think you are right. Repeat.
mg sine theta mg in sine theta into x minus kx square by 2 equal to v square by 2. That is the equation I'm getting.
Yes, that is correct actually. That is correct. So it is x mg sine theta minus half kx square, I think. Yes, minus half square equal to v square.
V square
mv
by
square.
2.
mv square. There will be
Yes, m should be there.
mv square by 2. V square by 2. Yes, correct. That is correct. Yes. Yeah, Ramchandra, did you get? Okay, you might not have get, so I'll just tell you.
Yes, sir.
Yes. Yes. Okay, see, so this is my geometry. Okay, so what is force on the block M actually? It is mg sine theta.
Hmm.
It is mg sine theta, right?
Yes, sir.
Huh? That this is in this direction force, and there will be opposition force by the spring, which is minus kx. Correct?
Yes, sir.
Now this should be equal to mass into acceleration. Right? Is there any other force on block M?
No, sir.
There is only gravity and spring, right?
Yes, sir.
So I have considered the gravity, I have considered the spring. So this should be no mass into acceleration. I can add acceleration by v dv by dx.
Sir, it will be D. Yes, sir.
Okay, and I'll take this dx on this side. And I'll solve the equation. So this side is a function of x only, and this side is function of v. So I'll get a v, right? Okay.
Sir, there their theta component is also there, no, sir.
Theta is there. Say this sine theta constant, hai na?
Hmm.
Theta is not changing. Why are
Yes,
you?
yes, sir.
Why are we changing the slope of
Yes, yes, sir.
wedge?
If slope may changes, it will change. Yes.
Slope क्यों change होगा? बताओ मुझे.
No, no. If the wedge is like a parabolic shape, then there is a chance.
Why? I never said wedge is parabolic shape. I mean, you're changing the question. Obviously, the answer will change, na?
Yes,
Why
sir.
the wedge will be parabolic?
Oh, no, sir.
Okay, great.
Yes, sir.
Yeah. So Tejaswar, can you please come back?
Sir, can we say like by energy transmission, like can
Yes.
you solve by energy method?
Yes, we can. We can do that as well. So in that case, the three type of the gravitational energy, loss in
Hmm.
gravitational energy will be equal to gain in kinetic energy and gain in spring energy. Okay.
Yes, sir.
Yeah. So that will be something like, I think, mgx by sine theta. That should be equal to half mv square
Yes.
plus half kx square. Okay.
Hmm.
And then we can solve that as well. Divide it with t. Sorry, differentiate with t. And yes, we can get it. Okay. Yeah.
Sir,
Tejaswar.
can you
Yes,
draw
sir.
the graph, like
See,
a final graph?
see, graphic actually it's v square equal to something of function of x square. Okay.
Yes, sir.
Yeah. So graph is something like v equal to under root a parabolic function or under root a quadratic function. So it's not exactly a parabola. Are you getting it?
Like, can you show on graphs, sir, so that I can understand?
Okay. So what do you want me to tell?
Like the final question, like with respect to x, so the velocity graph.
See, if I solve this expression, I'll take this dx here. Okay. What will I get? I will get mgx sine theta
Hmm.
minus half kx square is equal to mv square by 2.
mv square by 2. Yes.
Correct? Now I'll
Yes,
take
sir.
this mv
Yes,
on
sir.
that side as well. So it will be multiplied by 2 by m. Okay. Something like that.
Hmm.
And this is v square.
Hmm.
So I'll take square root of this side.
Yes, sir.
Yeah. So don't think too much about graph exactly. How will be the graph of this equation? But the expression is more important. Okay.
Yes, sir. Like x minus x square. I think that graph is difficult
Yes,
to
x
draw.
minus x square and under root graph. Yes. So x minus x square will be x is this, x square is this. So x minus x square will be this height actually. So something like this, and its square root. Now it is between 0 and 1, so square root of that will be little higher than that.
Yes,
Okay.
sir.
Yeah. So
Yes,
something
sir.
like that. You don't need to be very specific about
Sir,
it.
sir, if you see that it is looking like sinusoidal only, like if you observe,
It is
like
looking,
it
but
look
is it
like
sinusoidal?
it's
It is
not
not
sinusoidal, but
sinusoidal.
it is not sinusoidal, but it looked like that. Like I think I'm
See,
getting your.
see, what is point is sinusoidal has a very definite shape that is defined by sine theta.
Yes, sir.
Okay, so calling it looking like sinusoidal is not a very appropriate
No,
thing to do.
no.
But yes, it is. It
Yes, sir.
does look like sinusoidal, but it's not sinusoidal. That's what you
Yes,
should say.
yes, yes, sir. Yeah,
Okay,
yes, yes.
I
That's
agree.
what I
It
was
looks
saying.
like
Yes.
sinusoidal, but a
Hmm.
better appropriate will be it look like more like a parabola, something like that. Okay, because
Ah,
at
yes,
least
sir.
there is some type of parabola here.
Yes,
There
sir.
is no sine theta here. Is there any sine?
Yes, sir. Hey, there is no sign, but
There is no
what I'm
sine.
saying is the graph look like something like SHM.
But no, it's not SHM.
It
It
is
will
not
be.
SHM, sir. Like, yes, sir. Yes, sir.
I got your point, but still, that's not
Yes,
a
sir.
very precise thing to say. You can at
Appropriate
least
thing.
say
Yes.
parabolic. Yes, you can at least say parabolic. It's still not parabolic. Parabolic needs an x square,
Yes, sir.
but still at least it's
Mm.
under root x square, so that is little bit valid than other one. So it is more correct than sinusoidal one. That's what I'm saying. Both are wrong,
Yes, sir.
but one is
Yes,
more
sir.
correct. Yes. Okay,
Yes.
Tejaswar. So
Yes, sir.
yes, you okay? Yeah, just like I said. First you say diploma, then you say about your degree, okay? Then next thing
Okay,
is
sir.
you don't need to tell your school was 600 meter away from your home, okay? That's little redundant to be honest, okay?
Okay, sir.
Yeah. Then I think you need to go through a little bit revision, okay, at this stage. You
Okay,
have
sir.
knowledge, obviously, but I think you should brush up your concepts. That will be good thing to
Okay,
do.
sir.
And I really like you don't get fear or anxiety. That is really nice actually. I mean, you are not nervous when
Thank you,
when
sir.
I'm interviewing you. You are not nervous. Like you just saw, let's say Vamsi. Okay, in the beginning he was little nervous, right? But as
Yes, sir.
soon as told him to be confident, he improved that. So I mean, that's how one should be. So you don't even need to improve in that particular zone. Okay, that's
Okay,
good
sir.
actually. Yeah.
Okay, sir.
So yeah.